Hi, in this video of Code G, I'm going to be continuing with the first unit of statistics, and now that we have done mostly what all theoretical concepts that we need to do from this chapter, I am now going to be starting with the actual portions where the numerical portions kind of come in. But before doing that, I would like to highlight a few other things which are basically a culmination of everything that we've discussed so far, but it's good to have it in one place so that you know that this is the starting point of the things that follow from here. So if you recall, so far we have distinguished between populations and samples. When we distinguish between populations and samples, I said that a sample is essentially a subset of the population which is studied in order to make inferences regarding the population. Also, when I say population, I naturally mean population of interest. I'm not going to be, saying this population of interest over and over again. But when I say population, for the most part, it will imply that I'm talking about the population of interest. In case I'm not, then I will specify it clearly. But from now on, from this point forth, if I say population, I mean population of interest. So, you know that you take a sample which is a subset of the population, you study it in order to make inferences about the population. The other thing that we had done was that the entire point of using statistics is because you have uncertainty, and statistics helps you summarize data. It helps you summarize data. This, in the background of this, what we are basically saying now is that you essentially use a summaries of the sample in order to make inferences regarding summaries of the population. Now, what do I mean by summaries? That is exactly what we're going to do in this video. Summaries could mean things like averages. Summaries could mean things like median, mode, variability, variance. It could mean a lot of things, right? The point is, when you talk about summaries or summary measures, right? So ideally, you want to describe what the typical data looks like, or typically. So a summary is kind of trying to answer the question, typically, what does my data look like? What does my population look like, right? Now, to answer this question, a summary statistic or a summary, so summary, I can also call them summary statistics. Summary statistics can be of multiple kinds. I could be talking about, okay. So, like I said, the summary could, be of different kinds. There could be different types of summary statistics. Primarily in your course, there are two types of summary statistics. There is measures of location, which tell you literally where is your data located, right? And there is measures of variability, which tell you around that point where your data is located, how much does it vary. So what is it that it looks around that point? Measures of location tell you what is that point, okay? Measures of variability tell you how your data behaves around that point. That's the basic difference between the two. Measures of location tell you कि data कहाँ पे है. Measures of variability tell you कि जहाँ पे data है उसके आसपास data कैसे behave कर रहा है, okay? So now for this video, we're going to be focusing on measures of location. Primarily, you would be familiar with three measures of location in life. You would have heard of mean, which is basically referring to the arithmetic mean. I'm not going to go into what other types of mean are there. That's not, something that concerns us right now. You would be familiar with the median, and you would be familiar with the mode. Now, the mean basically tells you what is the typical observation. Median and mode also answer the same question, but in slightly different manners. The median tells you what is the middle observation. Irrespective of whether or not it is typical, the median is telling you what is the middle observation. Okay? The mode, on the other hand, is telling you what is the most frequently occurring observation. So each one of these is giving you the answer to a different question. But at the same time, they're all measures of location, because they're telling you what is it that your data is going to look like. What is it that your data, where is it rather that your data is located. Okay. So now another thing is that, now that you know that these are the key measures that we're going to study, the next thing to sort of understand is what are the data types for which we're going to study it. In your book, the only data type for which these things are given, actually, your raw form of data, which is basically to say that, if you have 10 people and let's say the age of those 10 people, then, it's listed as it's basically a list of numbers. So it's like 20, 21, 32, 34, 35, 37, 40, 50, 60, 62, and 64. Okay, so this is this is kind of saying that this is the age of a sample of 10 people, and then depending upon, so this is basically data in the raw form. In this raw form, you can have formulas for the mean, median, and mode, respectively. But obviously, this is not the only data type, right? There are other data types that could be there. So this is the raw data. I'm going to call it the raw data for now. The other type of data that you can have is discrete data, so discrete data basically means that the data is not grouped, but at the same time it's also not raw, because you have or X, which is, let's say, a variable of interest, so it's a univariate data set that I'm considering, and then you have your frequency. So this is telling you, okay, for example, if you talk about cake cooking times, then I'm saying that 20, 25, 30, 35, 40, and let's say you have something like 6, 8, 2, 5, and 10. So I'm saying that 6 people are taking 20 minutes to cook their cake, whereas 10 people are taking 40 minutes to cook their cake, and so on and so forth. This is a form of discrete data. Similarly, you could also have grouped data, right? So both of these are ungrouped naturally. The other type of data is grouped data. Grouped data would look something like, so if I, let's say, have scores of a class, then it could be something like, on a test out of 50, it could be you could have 10 to 20, 1 to 30, and 31 to 40, and 41 to 50. And you could have, again, so this is your X, and this is your f of X, which is your frequency. You could have 3 people scoring here, 5 people scoring here, 6 people scoring here, 10 people scoring here, and this is a class of 24 people then, right? So the point is, these are the 3 ways that your data can look like, and for each of these 3 ways you will have to know how to calculate the frequency, the mean, the median, and the mode. When I say mean, again, for now, let's just assume that I will refer to arithmetic mean. I'm not going into what other kinds of means can there be. I'm just referring to the arithmetic mean, and I'm call it the mean. Okay, so for each of these data types, there are different, not different ways, but there are specific ways to calculate the mean, the median, and the mode. And I'm going to look at all of these data types for you, because this is something that is important as a statistics life lesson. Also because while this is not something that the book kind of explicitly states anywhere, it's also not something that you are not kind of expected to know if you're taking up a course in statistics. So while the book only gives us these kind of things for the raw data or raw form of data, we are going to be looking at it for the discrete and the grouped data as well. The last thing that I would like to point out before we actually get into the actual study of mean, median, and mode is that given that you are studying samples to conclude regarding the population, for each of mean, median, and mode, it's important to know that you would have a different statistic for every sample and then a different statistic for the population. For example, if you use a sample of students to calculate the marks of a class, then so let's say the class is of 50 people, and you're using the scores of 10 to calculate the mean of the mean score, then the sample statistic is going to be represented by X bar, whereas the population statistic is going to be mu. In the same manner, the median for the sample is going to be X tilde, whereas the median for the population is going to be mu tilde. Mode in a similar manner is going to be so for now I'm going to call it M bar and M. Okay, M bar is the mode of the sample and M is the mode of the population, and so on and so forth. So my point is that that there is an important distinction which you can draw between the same statistic for the sample and the same statistic for the population, and it's important that you understand that the two will be different. You use the statistics of the sample to conclude regarding the statistics of the population. Generally you don't know the statistics of the population, which is why you have to take samples and calculate the statistics for the sample to get to the population or to get to understanding the population. Okay, so that's it for this video. I'm going to stop here, and in the next video, without giving you all of this background, which I have spent a great amount of time doing in this video, I am going to directly start by the actual calculations for the mean, median, and the mode, which is the measures of location. Thank you.